Welcome to the lair of the Batty Boffin.
Hi there Batty fans, time for a little bit more on equations with the Batty Boffin. Now in earlier videos I've introduced the method of solving linear equations by writing down what we're going to do on both sides, and sometimes we draw little circles around things to help us remember what order, sometimes known as the Cadbury's cream egg method. Other confectionery is available. So we're just going to have a little bit of practice in this video here. If you have no idea what I'm talking about and I say linear equation then it goes whoosh, then look at some of the earlier videos where I explain them a little more. But here I'm going to assume that you have seen this method before. I'm going to give you a demo with this purple one, and then you're going to have a go at the green one and the blue one using the same method. So here we go with the method. What I'm going to do to start off with is identify the order in which the operations go, the ones that are kind of like closest in to the x. This is BIDMAS or BODMAS or PEMDAS, however you use it on here. So x we've got, imagine that's the prize in the middle of a pasta parcel and we're wrapping up in 2 layers. We've got a times by 6 layer and we've got a take away 7 layer. And BIDMAS tells us that the multiply is a closer in thing than adds and subtracts. So those are our layers, and we get rid of the outer layers first, just like a pasta parcel. So to get rid of that outer layer, which is a takeaway 7, how do you get rid of a takeaway 7? You add 7. Whatever you do on the left, you do the same thing on the right. So the left hand side becomes 6x, because we've got 6x take away 7 and then we've added 7. So those two things, you might as well not bother doing either of them. So the left hand side becomes 6x and the right hand side is 29 plus 7, which is 36. Now we need to get rid of that times by 6. So we do a divide by 6 on both sides. This side becomes x, the right hand side becomes 6, and there's our answer. Okay, and we know that that's true because if we take x equals 6 and pop it in up here, 6 times 6 is 36, take away 7, 29. Yep, that works. Okay, hopefully that method looks vaguely familiar to you. So the basic thing is whatever you do on the left, you will do the same thing on the right. And if you're not sure which order to do them, then use this Cadbury's cream egg method. Start off with the x in the middle, identify what kind of thing is closest. Brackets are the closest in, and then I for the index or O for other stuff. That's things like powers and roots. They're the next closest in. After that, divides and multiplies. After that, adds and subtracts. So, using that, could you please pause the video and have a go at the red one? Right, let's have a look at that together. We've got the same kind of thing with the ordering. X is the prize in the middle of the pasta parcel. The times layer is the closest in, and the add layer is the one on the outside. So we get rid of the outer layer first. How do you get rid of an add 2? Take away 2. Right hand side becomes 55. You can probably see the answer at this point. And the left hand side is 5x. But just to show that we're doing it properly, we're going to write a divide by 5 on both sides. Left hand side becomes x. Right hand side becomes 11. Okay, so pause the video and have a go at the blue one. Right, the blue one is very similar. Again, we've got the multiply layer, that's the closest in, and add and subtract on the outer layer. So we're going to get rid of that take away 6 for starters by adding 6. Gives us 4x equals 28. Hopefully you know your times tables here, because you should hopefully recognise 28 as 4 sevens. So when we divide by 4, we get our answer of 7. There. I hope those made sense to you. What I'm going to do is wipe down the board and then we're going to come back with some more 2-stage questions, but they're not going to be quite like this. These are all very simple. You know, we've got a times, we've got an add or subtract. Next time I'm going to maybe put some brackets in, maybe put some divides in. We'll see what they're like. I'll see you in a minute. Right, here are three for you to have a go at. We've got a couple with brackets in, and we've got some bits with divides in here as well. That's the one way of showing a divide. Of course, there's another way of showing a divide. So, if you find it useful to put the little Cadbury cream egg rings in, then do that, and off you go with the purple one. Let's look at that together. Bidmas, Bodmas, PEMDAS, whichever you use for that, tells us that the brackets are what we do first. So the closest in layer here is the add this time, and that's because of the brackets. And the outer layer is the 5, the times by 5. So we get rid of the outer layer first. So we're going to do a divide by 5 on both sides. So the left hand side becomes x plus 2. We don't need the brackets anymore. They're not wrong if you put them in, but it's fine, we don't need them. And the right hand side, 45 divided by 5 is 9. Okay, easy from here on. Take away 2, and the left hand side becomes 7. We can check that. 7 plus 2 is 9, 5 9s are 45. Yeah, that's right. Hope you got that. Have a go with the red one now, please. We do this one very similarly to the purple. Again, the brackets are what we do first, so this added 5. Please note it's written the other way around, 5 plus x. 5 plus x is the same thing as x plus 5, so that's not a problem. But watch out if that's a takeaway in there. 5 take away x is not the same as x take away 5, so just watch out for those. So we've got the add layer is first, and then we've got a divide layer on the outside, and we get rid of the outer layers first. We're going to do a times by 3 to get rid of the divide by 3. So the left hand side becomes 5 plus x, and the right hand side becomes 18, not 2. I've seen people put 2 on there, okay? When it's a divide by 3 on that side, we're not going to divide over here, because what we're doing is timesing by 3 to get rid of the divide. So whatever the operation is, it will always be the other kind of thing. Adds become subtracts, subtracts become adds, multiplies become divides, divides become multiplies, because what we're doing is we're getting rid of that thing. So to get rid of a divide by 3, we're doing a times by 3, which means both of them disappear, because they kind of cancel each other out, but we end up with a spare times by 3 over here, so that's why it's a multiply 18, not 2. And then we've just got to get rid of this added 5, so we can take away 5 on both sides, and we end up with an x equals 13. As I say, just be careful on there. If that were a takeaway, you couldn't just add 5 to get rid of it, but we'll do some of those later, you'll see why. Okay, so hopefully you got 13 on there, and we can have a go at the blue one now. Now the blue one looks a little bit different because of this fraction in it. But a fraction is just a divide. So on here there are no brackets, no indices, that's the I or exponents for PEMDAS or other stuff, orders for the BODMAS. The next thing we're down to is the divides and multiplies. So here's a divide or multiply, and then we've got our add for the adds and subtracts at the end. Okay, so getting rid of the outer layers first, we'll get rid of that add 4 by doing a take away 4, which gives us x over 7, or you could write that as x divided by 7 if you prefer it that way round, and that equals 2. And then to get rid of the divide by 7, we're going to do a times by 7 on both sides, gives us an x equals 14. Okay, 14 is what you should have had for that one. I hope you did okay with those. Moving on into the next video, we're going to be looking at some 3-stage equations, which are exactly the same thing, except instead of having 2 loops, we're going to have 3. So I'll see you then.